Okay, good morning, dear students. Today we will learn about the class equation of non-abelian group. In our previous lecture, we already learned about the class equation of the abelian group, and we knew about the basic concept of the class equation. The class of any group is divided in the form of the order of the centralizer of the group plus sum of all those elements A not belongs to the center of Z and order of Z upon normalizer of the elements of Z, okay, and normalizer of the G. This is the process for finding the class equation of a group. But if basically we have two cases. One case is group is abelian and other case is group is non-abelian. Okay, we have two cases. One is abelian. If group is abelian, then we know that every element of the group is the self-conjugate. It means all the elements are self-conjugate. And if all the elements are self-conjugate, then the abelian group, the group is always equal to the center of the group. It means all the elements involved in the center of the group. That is, if all the elements involved in the center of the group, then this part is negligible for such type groups, and we can write the class equation of the group like class equation of abelian group equal to 1 plus 1 plus 1 plus 1, and number of the one involving in this group are equal to the order of the group. Okay, order of means number of the elements in the group. Always this part divide in the form of 1 plus 1 plus 1 plus and so on. Okay, student. But in case of the non-abelian group, we have many non-abelian group, and in this case, first we need to calculate the centralizer of the group. Then we need to calculate the order of the group and normalizer of the group. Then finally we can construct the class equation of such type group. Okay. For understanding this, so we can for understanding this we will practice on the such type non-abelian group. For example, quaternion group. Let us take an example of quaternion group Q4, dihedral group D4, quaternion group Q8, dihedral group Q4, and other groups we have which are non-abelian in this case. Okay, for example D4. Let's take an example D4, dihedral group of order 8. In this group, the order of D4 is 8, and this is first we need to understand about the dihedral group. Dihedral group is a group of the rotational of a polygon. And in this type of the group, dihedral group, suppose that we have D4 is a group of rotation of a rotation of a cube, or rotation of a cube, rotation of a square. Okay, rotation of a square. And in this type of square, we have points of in this square is A, this point is B, this point is C, this point is D, and we need to know about how many times we will rotate this cube, this square, to know the same image. Okay, हम कितनी बार चेक करेंगे कि ये सेम इमेज देखेगा, हम कितनी बार इसको घुमाएंगे, इस स्क्वायर को कितनी बार हम घुमाएंगे कि हमें सेम एक जैसे स्क्वायर मिले. ओके, फॉर एग्जांपल अगर मैं इसे पहले किस टाइप से घुमा सकता हूँ, we can rotate it horizontally, we can rotate it vertically. This is a rotation of vertically. Then we will find the dv, and we can rotate it horizontally, we can rotate it about this diagonal, we can rotate it about this diagonal, and other is revolutional. So first we have the number of the elements of this group is when we rotate it this position. अब हम क्या करेंगे, इस पोजीशन को क्या ले लेते हैं, this position is R0, there is no rotation. When we rotate it in 90 degree, then we have R90. Okay, when we rotate it 90 degree, then we have the shape of this diagram is A, this is B, this is C and D. Okay, this is R90, 90 degree पे rotate हुआ R90, then is R180. You can rotate the 90 in 90 degree, then it is A, B, C and D, and then again is R270. Okay, then again is A, B, C and D, then again is R360, and when we rotate it in 90 degree, then we have the initial cube, no, sorry, initial square. Okay, again we have R0. अब हम क्या करेंगे, इसमें वैसे हॉरिजेंटली घुमाएंगे. अगर हम हॉरिजेंटली घुमाते हैं then this shape is C convert in हॉरिजेंटली घुमाएंगे तो B यहाँ चला जाएगा ऊपर, B and C, and this is A and D. Okay, then this is R H, R horizontally. Okay, similarly हम इसको कैसे घुमाएंगे, वर्टिकली घुमाएंगे, then ये सेम दिखेगा R vertical, and then we can rotate it R diagonal, R first diagonal, R second diagonal, and this R first diagonal and second diagonal. These are all the elements of D4. In D4 we have 8 elements. These are all the elements of D4, and in this process we can find all the elements of D4 which are involved in the rotation and revolution process of a square. Okay, and now we can observe that this group is non-abelian. Okay, for example, when R horizontal rotate with 90 degree, R horizontal rotate with 90 degree, then this is the horizontal. Where is horizontal? When R horizontal, this is a horizontal, rotate in 90 degree, then the resultant of this is when it rotate 90 degree, then this is A, this one is A, D, C and B. And when R90 rotate horizontally, R90, this is R90. Okay, and when we rotate it horizontally, this is horizontal, then B cover here, B, A, and this is C and D. Now this R horizontal rotate 90 degree, and R horizontal R90 rotate horizontal, then we have two different image of this figure. It means this is not satisfy the commutativity, and this group is not an abelian group. This is non-abelian group. Okay, student. In our next lecture, we will find the class equation of D4. Okay, in our next lecture, we will understand and we will learn the class equation and process for finding the class equation of D4. Thank you.